In this live example, we are going to create two functions that are going to do the opposite effect of each other. The first function is going to take an angle measure in decimal degrees, like we see on the left-hand side of the two test cases, and it will make a conversion into the degrees, minutes, seconds form, DMS form, like we see on the right-hand side. Then we'll make a second function that will do the opposite, take in the DMS form and then output the decimal degrees form. This DMS form that we see on the right is useful in navigation systems, either at sea or in air, that prefer to use the minutes and seconds form rather than the decimal form here. But if you're unfamiliar with it, the minute is going to be 1/60th of a degree, and then a second, denoted by the two apostrophes here, is 1/60th of a minute. So a degree, a minute, and a second is what we are doing the conversions between. Going into MATLAB, we'll start writing our functions. So we were asked to make it as a function. So the first one I'm going to look at is converting from the decimal degrees into the DMS, the degrees, minutes, and seconds. So I'm going to call my output DMS here for degrees, minutes, seconds, equals, and I've actually already named this function, so I just have to make sure that it has the same name as the file name. So I call this comp sci 200 L02 degree A, and then the other one will be B. And I will call this input DD for decimal degrees. So I'll just form this skeleton here to do my conversions. Okay, so let's see what we are to do. We're going from the left side to the right side in the two test cases. So let's concentrate on the first one first. The 24.46 is going to become 24 degrees, 27 minutes, 36 seconds. But if we look at the bottom one, the negative 49.67, we have negative 49 degrees there. So when we are converting from the decimal form to the DMS form, we notice that the integer part, the whole number part before the decimal, is going to be the same as the number of degrees we have in the DMS form. So what we want to do is from the DD, we want to kind of pick out just the stuff to the left of the decimal, because that's going to be the degree for the DMS form. So how can we do that? Let's take, there's a couple different options here. I'm going to use floor, should work. So let's see what floor does. If you're not familiar with it, you can look it up. So floor is going to round our number towards negative infinity. So basically what we want is a rounding, because that's what rounding does. It takes a number that has a decimal and it's going to round, well, depending on how we define it, we want to round it to just an integer of that. So for example, if I do floor of the 24.46, it's returning just 24 because it rounded it down towards negative infinity. So I can do that same thing here. But let's check also the negative 49.67. Oh, actually floor is not what we want. So if we see here, floor doesn't work with the negative number because floor always rounds it towards negative infinity. So it rounds it down. So actually floor is not what we want. The fix is actually what we want for this. So let's look at what fix does. Fix rounds towards 0. So fix rounds the elements to the nearest integers towards 0. So actually fix is the one that's going to work for us. It should. So let's just quickly test it. That gives us the 24, so that's okay. And the negative 49.67, this is correct. This is just going to pick off that whole number part. So actually fix is what we want. So let's say degree, deg, I'll call it. So this will be calculate degree segment of DMS. Okay, so that's going to pick off, like we see in the two examples, the 24 and the negative 49 part. So what we are left with is then that decimal part. So let's see what we have here. If we have, I'll just test it in the command window first. The 24. Right, so the 24, so that's good. So with the 0.46, that is how much kind of as a decimal or as a fraction of a degree we have left. So I want now to work with just that 0.46, or in the other case, the 0.67. So let's see what we have here. What we can do is I can do my dd minus deg, and that should give me the fractional part or the decimal part. So let's just see, is that correct here? So I want, I think it is, yeah. So if I do 24.46 minus fix 24.46, okay, that will leave me with the 0.46 part. And does that also work for negative 49.67? And that leaves me, yes, with the 0.67 part. So this is right. I want dd minus deg. So this will be just the decimal part of dd. And I need to save that to something. I'll call it, I guess, frac for right now. All right, so I have the whole number part, the degrees part, and now I have just the fractional part being calculated. So what I can do is, so the fractional part, like that 0.46, that is going to be like 46/100ths of a degree. So we know that a minute in the DMS form, a minute is 1/60th of a degree. So 60 minutes would be 1 degree. So what we have here is frac times 60 should be what we want. So if I take like 0.46 times 60, I get 27.6. So I have that 27 part. And for the other example, the 0.67 times 60, that gives me the 40 part. So what it looks like is when I do this calculation, again, the stuff to the left of the decimal will be how many minutes we have in the DMS form. So frac times 60, and I want, actually this too, I want to fix. So let's see what happens there if I do what I just did and I use the fix. I have the 27 for the first one, and I have the 67, the 40 for the second one. So this actually gives me then the minute part. So I'll call that min. I'll call it mn for minute. I don't want to use min since that is a reserved function in MATLAB, so I will call it mn. So minute part of DMS. I guess I'm calling it segments, so I'll be with that segment. All right, now I still need the seconds. Well, a second is 1/60th of a minute. So we see we actually have some leftover stuff again. So I can do mn minus frac times 60 should work. To get me just the decimal part of what I have left over. So again, for the first example, I have this 0.46 times 60. That was 27.6. So if I take that 27 part, actually I want to do the opposite here like I did before. So frac of times 60 minus mn. So if I have 0.67 times 60, right, minus the fix of 0.67 times 60, which is what mn was, that gives me the 0.2. And that's what I wanted because it was 40.2. Well, I'm on the other one, so yeah, so that's right. So 40.2, so this is calculating just the 0.2 part. So that's saying that of the minute, which was originally in decimal form, I just wanted the whole part of that, and I'm left with that decimal part, the 0.2. This is what I can use to then calculate how many seconds I have. So I have the frac times 60, get rid of that there, minus mn. And this will then be my number of seconds. No, actually, this is going to be my frac 2. This is my second fraction. this is decimal part of minute calculation. Okay, so let me just see how it's working so far. I'm going to do a little bit of the debugging. So I'm setting a breakpoint so I can step through this one at a time, one of these lines at a time. So I'm going to call my function, and I'll use the first test function, 24.46, to see how it's working. Okay, so I'm going into my function. The breakpoint, it stopped at line 6 as it should. So I can keep track of my workspace. So DD came in 24.46, that first test case. So that's good. So I'm going to do a step. Now we see it went one more line, so it computed my degree part, the 24, so that's good. I'll do another step, and it computed the fraction. That's the 0.46, so right, that's just the, off of the original input there, that's just the decimal part. And I'll step again. I have MN, that's the number of minutes then. That's coming from the 0.46 or the decimal part times 60. So 27, right, and it's an integer value, so that's right. And I step again, and it computes frac2, and that is my 0.6, and that is coming from that fractional part minus my number of minutes. So that is, well, the number of minutes is a decimal minus the integer number of minutes. So the last step here I still need to do is, let me stop the debugging here. I want to take frac2 and multiply that by 60. Because remember, frac2 is kind of how many partial minutes I had. So since a minute is 1/60th of a, or a second is 1/60th of a minute, then this will calculate how many seconds I have. So sec equals frac2 times 60. So decimal segment of DMS. All right, let me just run this again. I know the rest of this works, so I can stop it later. So 24.46, and if I do one step, number of seconds is 36. Okay, so that's what we were expecting here. All right, so it's calculating each of these segments correctly, so I'm going to stop my debugging again. I still have one more thing to do. I haven't defined my actual output. I'm calling DMS. So DMS is, remember I wanted this specifically to be a vector where each component of it was the number of minutes, the number of degrees, the number of minutes, MN, and the number of seconds. So I can define it this way, so I can take these three scalars and I can put it in these square brackets as a vector. And then that will be my output. So output of DMS as vector. And I can clean this up a little bit here now, put all my comments in the same location, so it's a little bit easier to read. And compact this now a little bit. All right, so let me try calling my function with both of my test cases. So I have here comp sci 24, okay, so 24.46 goes in decimal form and comes out in component form 24, 27, 36. So that's going to be degrees, minutes, and seconds. So that's correct. And with the negative, make sure that that works. Negative 49.67 goes in, and out comes negative 49 degrees, 40 minutes, negative 40 minutes, and negative 12 for seconds. So that's not what we want there. We just want the degree part to be negative. So we still have to fix this to make sure that those are positive. So actually it's going to be as easy as, well, I could do it here. I want these to only ever be positive, so I'm going to use ABS, the absolute, when I save it. That's probably the quickest thing I can do here. Let's try it again. Okay, now it's in the form we want. The degrees part is negative, but the minutes are positive and the seconds are positive, because we would express this if we wrote it out negative 49 degrees, well, just like it is on the slide, negative 49 degrees, 40 minutes, 12 seconds. Okay, so the first part is done, and actually I think this is going to be the harder function to do. Let's look at the second function. So we want to go in the opposite direction. So my other function, my output will be decimal degrees, and this one will be called comp sci 200 L02 degree B. And this will take in DMS. All right, so let's review here. So let me just put in a comment here. So input of decimal degree in as scalar, and output DMS form as 3-element vector. All right, again, I'll reiterate, this is a live example, so there's probably better ways to do this, but right now I'm just trying to get something functional and go through the process. So our other function, we want to do the opposite. So we have an input of DMS form as a 3-element vector, and our output is going to be a scalar in this one. Okay, so let's see, DMS is coming in as that vector. What we can do is take each component and we can use it separately. So let's say I'm going to take deg is going to be DMS of 1. So the first element of that DMS vector is the degree measure. And the minute is going to be the second element of DMS. And then the second is going to be that third component of DMS. And that is second measure. All right, so what I've done is when this comes in, I am going to pick out the first component, call it degrees, the second component, call it minutes or MN, and the third component of it and seconds, because I know that's the format that it's going to come in as that 3-element vector. So I need to construct then my decimal degrees. So decimal degrees is, let me just, this isn't right yet, but this will be the start of it. So I can start to test this. Decimal degree. Right now I'm just going to say it's equal to the deg part. And let me test this out just to see what it's doing. All right, now my input is that, so 24, 27, 36. And it gives me, well, just the 24. I know it's wrong, but at least it's returning something. All right, so I'm going the other way. I know that a minute, each minute is 1/60th of a degree. So I can add to this the number of minutes I have over 60. So if I had 60 minutes, I should be adding another degree. Obviously, I would just put that into the degrees column here. But this should work to include the minutes. Let's see, I get 24.45. That's not the answer yet because I also need the seconds. Well, 1 second is a 60th of a minute, and 1 minute is a 60th of a degree. So that means that each second must be, 1 over 60 squared, or 1 over 3600th of a degree. So I can add the seconds that way. So I think this should work. And if I do it, I get the 24.46, and that takes me back to my original, so that's good. But let's make sure, let's see if it works with the second way, 49, 40, 12. So this is not working correctly yet. Again, I think it's because, or it's definitely because of the signs. At least in the format I was expecting, I was taking that that 49, only the degree part had the negative, but now I'm coming up not negative enough. So I think what I want here, so the problem is, well, let's step through and see what's happening. So I'll put that breakpoint in, and let's see. All right, so DMS is in, the negative 49, the minutes and seconds I'm going to always treat as being, or assume are going to be positive. So if I step, degree comes out as negative 49, so that's right. This comes out as positive 40, so that's right. Seconds comes out as 12, so that's right. But when I'm doing this calculation now, I'm doing negative 49 plus a positive 40 over 60 plus a positive 12 over 3600, and it's coming out not negative enough because the negative sign was only on the degrees. So really this term, the mn in this calculation as I'm doing it, this term should be negative. It's positive for this case always. And this should be negative as well, but it's always positive because mn and SEC are always going to be positive, at least in the form that I'm expecting. So what I can do to correct that is in the case when I have a negative angle, mn and SEC should in this calculation be negative. What I could do is I can use this SIGN sine function on degree, and we'll see what this does in a second. So this will actually fix my problem, I think. Because, so let's step through again. Let me call this. And if I step and step and step, okay, so again, degree is negative 49, mn and sec are positive as they should be, but now what's going to happen is that this function, the sine of DEG, is going to return a negative if degrees are negative, and a positive if it's positive. So if I just run that, it's negative 1. So it's going to properly flip the sign on this to negative when my degrees are negative, and the same thing will happen here with the seconds. It will flip to a negative. So let's see if this fixed the problem that we were having for this negative 49, 40, and 12. Right, so by putting that in here, it has fixed it. Negative 49.67 is what we expected. But let's go back. Let's make sure it did not ruin the first test case, so 24, 27, 36. So that still works because in this case degree is positive, so the SIGN sign of degree is just positive 1, so that works just like it did before. And over here this is also positive 1, so that works properly as well. So adding in that extra little bit of logic here has now fixed it so that it works for a positive angle measure or a negative angle measure. All right, so let's just review quickly what we had here. So the first function, again, went from decimal degrees to DMS, noting that the DMS was going to be this triple, or this 3-element vector in degrees, minutes, and seconds. So that is how really we put it all together in this line 11 as a vector of scalar values. So the bracket, and then a scalar, a scalar, a scalar, and I wanted it in the form, so here I used ABS to correct the negatives that were coming out because I wanted only the degree part to be negative in my DMS version of the answer. So let me go up and just run this again so we see how that was working. So the 24.46, it came out as all positives, and for the other case, it came out, this was negative 49.67, that came out again only showing the degree as negative and the others as positive, and that's what we wanted. So the ABS fixed that, and I assembled a vector with the square brackets. In my second function that went in the opposite direction, it was actually simpler to put together the calculations here, certainly. I pulled out from that vector the first, the second, the third component. I saved it as DEG, MN, and SEC here as the pieces, and then it was as easy as adding the degrees to the minutes over 60 to the seconds over 60 squared. And then here I had to do kind of the opposite of what I did in the other function with the absolute. I had to put the sign back in to make that adjustment when I had a negative DMS coming in so that I got the proper calculation for the negative decimal degree coming out.